half of time. And we're back.
A little ad break.
Okay, so something I didn't comment on with number 6, but the domain is just whatever x values it takes on. So the domain of this function would have been from -2 to 3, which we kind of, you can kind of see, but just if you want to actually like note that. For number 8, what is our domain?
-2 to 3.
Yeah, it's also -2 to 3.
That's nice.
So, this graph looks something like, nope, not that.
Very strange looking graph.
That was excessively large.
Dot in the wrong spot again.
Alright, so basically it looks something like this. So, back to the question. At what points on the domain does this function appear to be differentiable?
Like all points except for x equals 0 and x equals 2. And
Are you sure?
and like -1.
Why?
Well, so we have like those 0 and 2, those are just discontinuities.
It's your
but
side limit thing.
I was
right?
gonna say the -1 is
Well, yes,
it's
for
one
that,
of those
but
corner thingies where the
yes,
one
it's a
side of the
corner. Because it makes like an absolute value, right? So it's a corner. So it's differentiable. Basically, we would say at all points. Oh no. At all points
I don't have
in
to write that terrible word.
-2 to 3, except at x equals -1, 0, and 2. Where is it continuous but not differentiable?
X equals -1.
X equals -1. Are there any points where it is neither continuous nor differentiable?
You got this one, Virginia.
No.
Confidence, Virginia.
I don't have confidence. No.
X
Yes.
equals 0 and x equals 2.
X equals 0 and x equals 2. So B takes out anything that's continuous but not differentiable. So basically any of these points that are left over have to go here.
Okay. And why is -1 one of them again?
-1 is continuous but not differentiable because it's a corner.
Okay.
So like when it's you have like a straight line, and then it just goes off in another direction in a straight line, right?
Okay.
So a V.
So like what would number 9 have?
Oh,
We're not going to do 9, but what would
that's a
9 have?
cusp.
That would have a cusp because it kind of looks like those birds that everybody drew as a kid. It's like, that's a cusp.
So the cusp is like a corner except rounded.
Basically, yes.
And do they have to like go like inward, I guess?
Typically, they kind of do.
Like
All right.
for number 4, would that be a cusp?
Probably, but it's hard to say exactly because that's like 2 totally different functions.
It's like it's half cusp, half corner.
Kinda, yeah.
I'm gonna call it cusper.
All right, this is your graph of 10. What the domain of this one? Oh, I didn't realize they were actually giving us the domains. The domain is from -3 to 3. So, where is this function differentiable?
So, well, I'll just say where it's not differentiable is like -2 and +2.
Yep.
All other spots are.
So all points in -3 to 3 except at x equals -2 and x equals 2. Or you could just write -2, comma 2. I don't really know why I wrote it like that.
I would have written it like that.
It doesn't matter, either way is fine, but the book writes them like all simultaneously when they give you the answers, but
Well, the book is funky. I think I'm understanding this section so far.
all right, B, where is it continuous but not differentiable?
-2 and 2.
Yep.
Hooray, I got one right.
So then where is it neither continuous nor differentiable?
Nowhere?
Correct. None.
What?
All right, these next ones, you're going to have to actually graph on your calculator to see them. They want us to tell, it says it is differentiable at x equals 0. Tell whether it's a corner, cusp, vertical tangent, or discontinuity. So 12, y equals x to the 4/5.
It's just the sign-up sheets
Okay.
for you.
Thank you.
Just put them in here.
You probably should tell people to give them to you.
Well, my name is on it, so hopefully they'll.
Hopefully people will just bring it to you.
If not, I'll just go through his box. He won't know.
That's fair.
It's one of those.
Did you get it graphed?
Yeah. I'll let you take this one.
Is it cusp corner?
Which
Cusp.
one?
It's a cusp.
Yep, it's a cusp.
Real disappointed y'all just not change names.
I was more disappointed when you changed your answer.
Oh.
Although I was disappointed in your lack of confidence in the answer.
All right.
Say with conviction.
14, y equals 3 minus the cube root of x.
Oh, that's the vertical one.
Yep, vertical tangent. 16, y equals the cube root of the absolute value of x. Thoughts?
That.
Bro. What?
It's looking kind of like some sort of.
Someone's hurting that child.
Oh.
That's on my grade field.
It looks like it breaks off. Like if you zoom in really close.
Take
Did you graph the right thing?
I think so. Does it kind of look like a cusp?
It kind of.
There you go. It's a cusp.
But doesn't it kind of look like it breaks off?
Yeah. I see it too. Zoom in some more. I
made
thought
my
it was a
lenses.
cusp, but
I made it -2 to 2.
well, mine is a lot closer than that. I just keep on zooming in. There's definitely some sort of break in with it.
Yeah, well,
Zoom in some more.
they told us it's not differentiable at x equals 0, but the shape is a cusp. It looks like a bird on my screen.
Look at the
I love birds.
a big bird actually.
Big bird.
No,
Big
The
bird.
yellow guy.
big bird.
All right, 18. Find the numerical derivative of the given function at the indicated point. Use h equals 0.001. Is the function differentiable at the indicated point?
Glad I know what H is.
Fx equals 4x minus x squared. And we're doing it at x equals 3.
I mean, so far that's about it. At least I know what H is.
So a plus h is now a plus 0.001. So our formula was,
Doesn't X equal A? Isn't that what the little thing is over there? It's A3.
yeah.
Okay,
So the formula was for a numerical derivative at a point, f of a plus 0.001 minus f of a minus 0.001 all over 0.002. So all we're doing is really plugging in 3. They just happened to tell us what h was in case you didn't have your definition given that way. So this is going to be 4 times 3 plus 0.001 minus, I need more room,
Oof.
4 times 3 plus 0.001 minus 3 plus 0.001 squared minus, I would bracket it, 4 times 3 minus 0.001 minus 3 minus 0.001 squared all over 0.002.
They're all over something. -2.
How'd you get that? I got 3,000.
I think you plugged something in wrong, hun.
Let me see. Let me just see this.
Oops. That's what I was waiting to say my answer. What did I do?
So this is yes.
Virginia.
What?
Okay. So, I think I found your problem.
What?
Okay. So, see that minus sign right there?
Yes.
supposed to be a plus.
Where?
Oh.
That made it go from -2 to 3.
And also, that thing is supposed to be squared.
Oh. Oops. Well, I wrote it down.
Alright.
In my defense, I had it right on my paper. I just wrote it down wrong from before. Well, if you do it and you switch the sign and you build a square, you get 3,000.
Oh, good
Just
to
thought
know.
that was,
All right,
Hang on
one
with the
more of
second.
these. F of x equals the absolute value of x minus 3 and x equals 3.
So, would we end up with anything crazy like 3,000? What are
I
the
mean, I haven't
chances?
seen one that comes up like that.
Anything like more than 100 or
If they end up being equal to 0, it's not differentiable at the point, just to make that clear.
Okay.
So I normally would just write this as 3.001. I wouldn't write 3 plus 0.001. I would just go straight to that. So when I do this one, that's what I'm going to do.
that's a good idea.
Eliminate some potential error.
Yeah, but yeah.
So absolute value of 3.001 minus 3 minus, now 3 minus 0.001 would be 2.999. So 2.999 minus 3 all over 0.002.
Yay. I see why you told us that other thing.
What is this? Why is it not differentiable?
Because it's at the whatever the thing is, because that's where
What's an absolute value?
it's a V, corner.
A corner.
That's where it goes to corner.
All right, your problems are 1, 5,
It's like
7, 11, 13, 17, and 23.